All right, folks, hello. We are going to be doing the last section in Chapter 2, 2-7, is linear programming. So let's get right to it. I'm going to get over there, and you'll see we have a problem on the board already. This is 2-7, linear programming. What we're going to do in this section is really combine a lot of stuff we've done in previous sections. We're going to be having to write some linear expressions. We're going to have to use those expressions in linear inequalities, creating a system of linear inequalities, and then solving that, finding the vertices of the feasible region that it creates. The feasible region is a new term. That's one that we talk about as a polygonal convex set before. And once we find those vertices, we are going to look at using them in a function that is related to the system we've created. And all of that will make more sense as we go through a problem. There's only one way to do these, is just to show you a couple of them and show you how I go about doing them and show you what the kind of the process is. All right, so what we're going to do is start with this problem. Stickit Inc. Stickit Inc. is, or Stickit Incorporated, makes X tons of Quick Stick and Y tons of Glue All every day. Now, what I do is first I just read through it just in general to get a feel for what the problem's about. And I don't do, not like my normal way of approaching word problems where I take notes the whole way through. I just do this first time through. So Stickit Incorporated makes X tons of Quick Stick and Y tons of Glue All every day. Each ton of Quick Stick produces 10 pounds of waste. Each ton of Glue All produces 20 pounds of waste. The City Council forbids the company to produce more than a total of 300 pounds of waste each day. Stickit has firm contracts to produce at least 6 tons of Quick Stick and at least 5 tons of Glue All. The total daily capacity of the plant is 20 tons. And the first thing it asks us to do, and I don't know why this is 1 and 1, it should be 1 and 2. No, I want this. This should be a 2. Sorry. Graph the feasible region. All right, when we talk about the feasible region, like I said, that's the polygonal convex set. In order to have a polygonal convex set or a set of solutions, we need a set of inequalities. So now I'm going to read back through this, and I'm going to look for things. Inequalities are always those less than or greater than type statements. So I'm going to look for things that say at least this much, or no more than, or less than, or this much or more. Those type of things that give us kind of a limit, and that limit is the inequality we're going to need to write. So I'm going to gather information, and then I'm going to find limits to write inequalities for. All right, so we're going to have to create our own inequality. Now, the first sentence, Stickit Incorporated makes X tons of Quick Stick and Y tons of Glue All every day. This one kind of made it a little easier than most do. They gave you what the variables were. If you look at this and this, it tells you what your variables are. Always write your variables down. It's something we look for when we grade these. So X equals, and always do it as a quantity, number of something, number of tons of Quick Stick was the first one, right? So X is number of tons of Quick Stick, Y equals number of tons of Glue All. All right, so we have our variables. Go to the next sentence. Each ton of Quick Stick produces 10 pounds of waste. Each ton of Glue All produces 20 pounds of waste. All right, so we just got some information here. And we're just going to write that information down. For right now, I'm just going to say, all right, they told us that, let's see, I got to go back a little bit farther. Each ton of Quick Stick produces 10 pounds of waste. So I'm going to say for Quick Stick, you get 10 pounds of waste per ton. All right, and for Glue All, you get 20 pounds of waste. So I'm going to go down here and say for Glue All, you get 20 pounds of waste per ton. All right. Oh, my pen just went crazy. I got to go up here real quick and do that. All right. All right, so that we got through that sentence. City Council forbids the company to produce more than a total of 300 pounds of waste each day. So they can't produce more than 300 pounds of waste. So they're less than 300 pounds or less of waste each day. So that we just had something about waste, and that's a limit. So the limit is 300 for these two things here. I'm going to write a waste equation. And if you want to color code these, I tend to color code them so when I graph them, I know which line is which. So for this one, if X is the number of tons of quick stick, then 10 represent the number of tons of waste according to how many tons of quick stick we make. And I'd have to add to that 20Y, because that's the amount of tons or pounds of waste per ton. And so this is the total tons or pounds of waste created by creating or making tons of glue all. And we know that total, they can't be more than 300. So we have our first inequality here. All right, so I keep reading. Go back to the problem. And we did that sentence. So now Stickit has firm contracts to produce at least 6 tons of quick stick and at least 5 tons of glue all. So again, we found something here, at least I did. I see that these limiting terms, right? At least. So they need at least 6 tons of quick stick and at least 5 tons of glue all. That means when they say at least 6 tons of quick stick, that means X has to be at least 6. So how do we say that mathematically? We say X has to be greater than or equal to 6. And when they say glue all, they need at least 5 tons of glue all, and Y is our number of tons of glue all, then we would say Y has to be greater than or equal to 5. Now notice I'm not trying to solve anything, guys. I get students that look at these problems and they try to do too much work in their head. I'm just following the process. I'm taking the information they're giving me and I'm trying to mathematically interpret it as inequalities. All right, that's all. The last sentence says the total daily capacity of the plant is 20 tons. So total daily capacity of the plant is 20 tons. What is that telling me? That means quick stick and glue all together, we can only make 20 tons. So how do I say that in terms of an inequality? Because that is a limit, right? That is a limit of the tons of production. So the number of tons of quick stick plus the number of tons of glue all has to be less than or equal to 20. We've got our last inequality. So we've got the pieces we need. Now, one thing I want to mention, if you notice my graph over here, well, you can't see all of it right now because it slid down a little bit. All right. If you see my graph here, I only did first quadrant, and there's a reason I only did first quadrant. I did first quadrant because when we talk about these type of real life problems, these linear programming problems, we're talking about situations that are only real numbers. They're numbers that are going to be, I shouldn't say real numbers, they're numbers that are the numbers that are greater than 0, because we can't have negative quantities of, say, quick stick or negative tons of glue all. So we're going to have positive quantities. So normally what I would have written down in this problem right off the bat in the very beginning, I would have probably said X is greater than or equal to 0, Y is greater than or equal to 0. And that's important to understand because that keeps us in the first quadrant. The reason it's not important in this problem is we have these two things where X is actually going to be greater than numbers greater than 0, and Y is going to be numbers. So these are ones that we can say, I don't necessarily need these to be written. But in problems that don't have limits or lower limits on their X and Y values, we would have to write those to keep it in the first quadrant, just recognizing that there's not negative values, okay? So now our job is to do number 1 in the problem. Number 1 in the problem said to graph the feasible region. So we've got our inequalities. Let's graph them now, all right? Since I'm already in the red marker, I'll just do X plus Y. Again, when I'm graphing an inequality, I graph the boundary, X plus Y equals 20, right? Intercepts at 20 and 20. So I need to make my graph just a touch smaller, or I can do this. Let's move it down a little bit. There we go. Now I got everything I need. So 20 to 20. Let's do that. So there to there, we're going to draw a line. So let's do this. Well, let's do this. And we'll stay in red, red. And we'll go from here down to here. Okay, so we have, oops, I wanted that red, but that's okay, I guess. And we have to shade one side or the other. Well, if I put 0, 0 in here, 0 plus 0 is less than or equal to 20, that would tell me I'm shading this side of it. So right now, we know with a normal problem, we know this is in the first quadrant. So right now we've got a triangle, so to speak, right here. All right. And let's go and do our others. If I do x is greater than or equal to 6, so x equals 6 is the next line I'm drawing. So x equal to 6 would be going, I need my line again, and I need it in blue, would be going straight through here. X greater than or equal to 6 would look like that. And I'm just going to use those there and there. All right, now, what side of this? Well, x has to be greater than or equal to, so we're going to use this side of it. So now we've cut off part of that triangle. We still have kind of a triangle here. And we're going to do y greater than or equal to 5. So y greater than or equal to 5 is y equals 5 as a line. So it's going to go through here. It might be a little high, but let's say it's there. What did happen there? Hold on. It gave me an extension somehow. All right, I don't want to do that. Let's do this now. All right, that's a little better. Okay, so we have that. And we have y greater than that, so it's this side of it. And we have an even smaller triangle kind of isolated here now. Okay, so finally, we're going to get to our green one, going backwards. 10x plus 20y equals 300. So 10x plus 20y equals 300 is our boundary. I'm going to graph this one using intercepts, because if x equals 0, y is going to equal 15, right? Because it'd be 20 times 15 is 300. And if y equals 0, then x would have to equal 30, because 30 times 10 would give me 300. So that boundary line is at x equals 0, y equals 15, so right there. And then at 30, 0, so over here. And we're going to connect those. So going from here to there. And we'll do, well, I didn't want lines, I wanted these. That's all right. I'll just cover those. And we'll do that. And again, looking at this, 0, 0 would make it true, right? The original inequality. So we're graphing below it. So we're doing this. So it appears that we have our convex set, the polygon that we were looking for. It would appear is right in here. Whoops, this is a bad recreation. It's all this stuff in here, this kind of triangle with the top cut off. So what I look at is that is my feasible region. That's what they wanted. Now, what I'm going to need from this are these vertices, right? And I usually label them so that I can write off of my graph what A, B, C, and D are. And, whoa, I did not want to do that. That's better. This is what I wanted to do. Okay, so what do we have? We've got A is the point, well, we know this was 6 and that was 5, so that's the point 6,5. We know B is the point 6 and where it intersects this line. So if x is 6, so if I, in this line, I plug in x equals 6, that would mean 60 plus 20y equals 300. So that means y equals, or 20y equals 240, and y equals 12. And that looks pretty much where we're at, doesn't it? Looks like our graph was reasonably accurate. So we can say this is 6, 12. C is the coordinates where x plus y equals 20 and 10x plus 20y is equal to 30. It's those intersections. Now it looks like it's at 10, 10. And if you have a good graph, sometimes you can just do that. Now, if we didn't know for sure or didn't have any way of checking, you might have to literally solve the inequality or the system that says I've got 10x plus 20y equals 300, and I've got the other one that is x plus y equals 20. All right, but because we can see on our graph it's pretty good, we could solve this system, right? You guys remember how to solve a system 2x2s. That was the beginning of this chapter. But if we didn't want to solve this and we wanted to say, well, does our graph tell us anything? It looks like 10, 10. Well, if it's 10, 10, it should make both of these true. So 10 times 10 would be 100, plus 20 times 10 is 200. That would be 300, and 10 plus 10 is 20. So that looks like we've got a good solution of 10, 10. And then finally, D, we know the y value is 5, right? Because it's at y equals 5, and it intersects the x plus y equals 20. So it's got to make that true. So if y is 5, x has to be 15. So this would be 15, 5. And we've got our 4 coordinates. All right, so we've graphed our feasible region. We've found the 4 coordinates of the vertices. It's going to say in the second part here, we've done the first part. We've graphed the feasible region. We've found the important coordinates. We're done with that part. The second part, suppose Stick-It makes $1,000 profit per ton of Quick Stick and $1,500 profit per ton of glue all. How much Quick Stick and how much glue all should Stick-It make daily to maximize the company's profit? All right, again, we're talking about maximizing or minimizing something here. That's important. This is that function related to our system. Remember in the previous section, we had a function related, and we just plugged in our values of our feasible regions vertices, or our polygonal convex sets vertices. Well, now we have to write that function related, and it's always going to maximize or minimize something because that's what those points do. Remember, we were finding maximum and min values at those vertices, the vertices of that polygonal convex set. Again, we're doing the same thing. It's just now a real life situation. So what would I have to do here? Well, what I'd have to do here is use this information to write that function. So we'd have an f of xy, a function regarding xy. And it's a profit function in this case because we're trying to maximize the company's profit. So the profit function here, would they make $1,000 per ton of Quick Stick? So 1,000 x, and they make $1,500 per ton of glue all. So that would be 1,500 y. And this would be my f of xy, the one that was given to you in the previous section, that function related to our system. Now we had to write it. Whoa, I did not want to do that again. All right, so now we go down and we use that. We use that idea that f of xy equals 1,000 x plus 1,500 y to try to find where the max value would occur. And we've got 4 possible areas. So if I do f of 6,5, f of 6,5 would be 6,000 plus 5 times 1,500 is 7,500, I believe. And that would be 13,500. And that's in dollars. That's profit. F of 612 is 6,000 plus 12 times 1,500. What would that be? Let's see. 12 times 1,500 is 18,000. So we've got 18,000 here, and that would give us 24,000. So that's a bigger max. Right now, that's the maximum. Let's see what else. F of 10, 10. So that would be 10,000 plus 15,000, and that's 25,000. Okay, and then F of 15,5. 15,5 would be 15,000 plus 7,500, 5 times 1,500, and you would get 22,500. And these are in dollars, sorry. So where does our max profit occur? It's 25,000 is our max profit, but look at the question they asked you up here. The question says, how much Quick Stick and how much glue all should Stick-It make daily to maximize the company's profit? How much should they make? They should make 10 tons of each. So our answer would be, that's where we get the 1010 gave us the 25,000. Remember, this was tons of Quick Stick. This was tons of glue all. So we'd say 10 tons of Quick Stick and 10 tons of glue all. And you have to be careful to do these things. Basically the way I showed you just now is what we're looking for when we grade these things. All right, we're going to have you turning in some of these where it's basically like homework, and we're going to grade them, and you get a point for writing down the variables. You get a point for writing down each inequality that you use. You get points for your graph. You get points for the vertices. You get points for, oh, I did that again. You get points for the plugging in each of the vertices into the function. You get, and the function itself, the f of xy, you get points for. And then you get points for this. But what I'm trying to point out to you is you can get a lot of points on problems like this without getting the final answer. All right. Now, there will be some that are multiple choice and they give you final answers, and you just have to figure out which is the best. Those are the kind of all or nothing. I like to give them where we're going to be going through and grading them, and you're going to see that we do that as we go through this. So you want to be able to write this all kind of organized. I can follow along with this. That's what we're going to look for from you guys. We're going to want to see that you did them this way. All right. I'm going to do another one of these examples on another recording. So I'll call that part 2. Just so if you want another example to look at, you'll have another example to look at. All right. Otherwise, you can start the assignment now, and we'll answer questions tomorrow. Have a great day, folks. And there we go.